Hello and welcome to the fourth session of the Building Safety Act 2022 CPD series, provided and presented by the Institution of the Structural Engineers. This session is being recorded for reference and sharing purposes. CPD is crucial for structural engineers as it ensures they remain up to date with evolving in the industry standards, technologies and regulations. With the introduction of the Building Safety Act 2022, structural engineers must stay informed about new safety protocols, risk management practices, and legal responsibilities. The legislation places a strong emphasis on accountability, transparency, and compliance with safety standards, particularly for high-rise residential buildings. It introduces new requirements for risk assessment, increased scrutiny of building design, and heightened responsibility throughout the building's life cycle. The legislation will shape how we approach building safety, require a more rigorous, collaborative, and accountable approach in our practice. My name is Human Bagi, and I'm hosting the CPD series as the chair of Southeast Super Region, comprising 4 hubs as annotated on the map. These CPDs are prepared and presented by the structural engineers within the region. The light purple area on this map shows where we are, who we are, and how we can support our members. For help and support on technical matters, CPDs, webinars, training, courses, and many more, please visit the institution website or contact the HQ. For those who would like to watch the previous sessions, they are available on the institution's YouTube channel, highlighted in blue. Please note the topics and dates that will be presented in due course. Please book your place soon, as the number of the attendees is limited. Please send questions via text message box. Will be answered either during or after the sessions. Without any further delay, I hand over to David to introduce himself and share his presentation. Thank you.
Okay, hi everyone. So my name is David Rivers. I'm a partner with Cundall. I've been working on structural risk assessments for the best part of 9 months now. So I'm going to hopefully kind of catch you up to where we've got to in terms of understanding. The plan for today's session, we're going to first kind of have a general introduction. We'll cover the legislative requirements and a bit more about what the safety case report is, and the kind of the bits that make it up and what the actual kind of act itself requires. I'll then give you an overview of the forthcoming ICRIT Guidance on structural risk assessments, talk a bit about data gathering and how we kind of get hold of information for desktop and visual inspection, then talk about the actual structural risk assessment process itself. There'll be hopefully a bit of time for questions at the end, although there's quite a bit to get through. But as Human mentioned, if you could drop questions in the chat as we go, the plan is that we'll do a Q&A transcript after the session. So if we don't have time to answer all the questions actually in the talk, we'll still kind of get responses out to everyone for those. The slides won't be available, but the session is being recorded and will be uploaded to the YouTube channel along with the other presentations if you want to come back to it. The slides are quite text heavy, but that's partly with a view to them being used as a reference in future rather than necessarily for today. So first things first, an introduction to the safety case report. So the need for the safety case report and generally safety risk reporting is obviously a direct result of the Building Safety Act coming in. That mandates that for all new and existing higher risk buildings, and I'll kind of get a bit further into what that means in practice in a couple of slides. For all such buildings, they need to have an assessment of their safety risks, and that's primarily from a structural and a fire perspective. The Act itself picks this up as part of clauses 83 and 84, which broadly just notes that building owners need to carry out an assessment and manage safety risks on their properties. It's statutory instrument 907 that more specifically elaborates as to what that means. So that sets out what it's called the prescribed principles in terms of that risk assessment process. So identifying building safety risks and then managing them in a suitable way. And it's the same statutory instrument that then actually explicitly introduces the safety case report as a means to do so. So broadly, that identifies that the person who's responsible for the building, the principal accountable person, has to work through a process to show that they understand their building and how it operates and any safety risks associated with it. That's obviously the kind of the pure legislation. What the HSE have done is on their gov.uk website, they've given a kind of slightly more user-friendly interpretation of what actually goes into a safety case report and what principal accountable people need to do. So this is as per the website reference in the bottom right. It's a very useful resource. There's a lot of content in there. I'm not going to go through all of it, but I will pick out some of the key points just to help set the scene, provide some context as to what the safety case report is looking to achieve in a wider sense, to then help contextualize what we as structural engineers will generally need to feed into that process. So first things first, purpose of the safety case report is fundamentally to set out building safety risks associated with high-rise residential buildings and how they're managed. The definition of a high-rise building is broadly 7 stories or at least 18 meters high, or and containing 2 residential units. I'll talk a bit more about that in a second. And as mentioned, it's primarily looking at safety risks associated with the spread of fire or smoke and with structural failure of the building. And there's obviously a degree of overlap between 2 as well, which we'll talk about later. Any such buildings must be registered with the building safety regulator, the BSR, before people can live there. So it applies to all buildings. So even new build high-risk buildings, before they can actually be occupied and used, they need to have a safety case in place. Obviously, the difference there is that if you've just designed and built the building, then the information hopefully is readily to hand. Whereas if it's a building that was built 10, 15 years ago, that may not be quite a straightforward process. So in terms of HRB definition, so the gov.uk website that I referenced goes into an awful lot of detail to help you define what is a higher risk building and to help principal accountable people to identify whether their buildings qualify or not. In basic terms, as I mentioned, it's a 7-story building or a building that's at least 18 meters high, and that height is measured from the ground level to the top occupied floor. So if you've got like a rooftop plant room or kind of green roof, etc., that doesn't necessarily count. There are all sorts of nuances within there. So if the ground level varies, or if you have kind of local occupied rooms and things, then there's a lot more guidance on the website. So again, place to look if you're sort of trying to clarify. In terms of the definition of a residential unit, it's I think, deliberately quite broad definition that it's a dwelling or any other unit of living accommodation. So there's a bit more explanation on the website, but it's, I think, deliberately vague to make sure that more buildings are included, certainly buildings where people will be there overnight and therefore at risk of any issues occurring. There are some exclusions that are noted explicitly within the guidance. So if the entire building is used for one of the following uses, so a hospital, care home, a secure residential institution such as a prison, hotels and hostels, or military barracks, those fall outside as long as the entirety of the building is used for that purpose. If you have, for example, a hotel where the top 2 stories are actually residential units, then that would still qualify as a high risk building. Broadly, the logic is that these are kind of more actively managed facilities. So if you've got a hotel, for example, you'll have a kind of concierge, you'll have a full evacuation plan for residents, and people obviously go to a hotel expecting there to be a fire escape strategy. If it's a prison, you'll obviously have active supervision of inmates, etc. In a residential unit, because people live there and kind of it's generally maybe a bit more free form, which I think is why those are treated differently. When is a safety case needed? So as I mentioned, that's needed from the second that a new building becomes, or before people can move into a new high risk building. Alternatively, if it's an existing building, you need to effectively, as soon as the regulator calls for it, or as soon as you become the PAP, if you're kind of taking ownership of an existing building. The plan is that these risk assessments and safety case reports are updated on a 5-yearly basis, is the current plan. So it's a kind of ongoing maintenance and update process through the life of the building. I've mentioned principal accountable persons already. So broadly speaking, any accountable person is someone who has a legal obligation to repair or look after a part of the building. And the principal accountable person is the kind of overriding person in control. It's usually an organisation, it's like a common hold association or a local authority, and they take ultimate responsibility for pulling together the safety case report. They aren't necessarily responsible for producing every single aspect of it, as we'll come on to, but it's their kind of global responsibility to actually assemble and submit the safety case and to register the building. As a final kind of introductory note, the BSR relatively recently have published their review criteria that they use for the safety case report reviewing. So it's effectively a series of tables that show the kind of areas that they're looking for and the questions they're trying to answer. So it's quite useful in helping to structure what they're looking for and what level of detail they're looking for. So that's definitely something to bear in mind. And that guidance, I'm sure, will continue to evolve over time as they review a larger number of safety case reports and start to find common issues and questions that they need to answer. Okay, so that kind of sets the scene more from a kind of global safety case report. The remainder of the presentation will focus more specifically on the role of structural engineers and how we feed into that process. And I'll start by giving you a kind of quick overview of forthcoming guidance from the ICRIT. So this document, so preparing safety case reports, this is currently going through final draft and review. The intention currently is for it to be issued in August, and it effectively is the ICRIT's kind of perspective on what structural engineers need to do to feed into safety case reports. Normally, guidance is based on standards and accepted best practice, but obviously this is all fairly unprecedented in the context of engineering. So it's had a fairly complex development process. There's been various groups feeding in, technical guidance from kind of relevant people, feedback from the industry and the regulator directly as well. So it's been a very much a kind of group effort, and it's taken a fair bit of time to pull all those various strands together. But intention is that it will then act as a kind of one-stop shop to help steer the process for structural engineers. The document itself kind of works through a kind of logical process of the different steps of that safety case assessment procedure. We will cover a number of these in the coming slides, but this just kind of gives you an overview of what's going to be in there. In terms of roles and responsibilities, so as I've kind of already alluded to, there's a whole number of people who feed into the wider safety case reporting. From a structural engineering perspective, it's generally this kind of purple box at the bottom, the technical team. That's where we will feed in. So as mentioned, it's the principal accountable person who is ultimately responsible for putting all of this information together and coordinating the team. And we, as structural engineers, will be providing our information to them. In terms of what that information would look like, the primary element is the structural risk assessment itself, which I'll talk about further, but there's kind of various other input across the board that will feed both into that risk assessment and more generally into the safety case report. So we have quite a few things to think about, but they all kind of fall under the same general review and assessment process. And in terms of that process, at a kind of fairly basic level, it's as shown on the right here. So the purple box is where I'll start, and that's primarily around data gathering, desktop review of information that's available, site inspection to kind of supplement that and find additional visual information. The actual risk assessment then follows, which is the green box, which I'll then cover in a later section, which is the actual review of the information itself and assessment of any risks or hazards, or risks and hazards that exist within the building and how those are managed. The ICRIT guidance itself is informed by a number of existing documents. So you've got various documents around assessment of existing structures, structural risk assessments for consequence class 3 buildings, structural robustness, etc. So it's putting together a lot of existing pieces of information into a new focus that hasn't really existed previously. And just as a final note on the guidance, so this isn't a formal part of the actual building safety BSA itself, but this is something the ICRIT has used to help kind of categorize and inform the risk assessment process. So if you're looking at an HRB, it's broadly dividing it into one of two categories. If it's a category A building, it's generally a new build building or a sort of newer building where there's readily available record information, there's a design intent, there's calculations, all of the kind of thinking and the knowledge that's gone into it is readily available and to hand. Effectively, they're the easy ones that hopefully have all been designed properly and kind of fully thought about. We typically have gone through the gateway process, certainly from now moving forwards. The majority, probably, certainly at this point, will fall into category B, which are generally older buildings that may have incomplete building information. They might have been through refurbishment or upgrades. They might be nearing the end of their kind of normal useful design life. So generally require a more involved and more considered risk assessment process. So this isn't a kind of category, and category A and category B isn't something that actually exists within the Act itself. It's just a kind of framework that the ICRIT has adopted. What I would largely be talking about in the kind of coming sections is really geared around the category B buildings. So first things first, some advice on data gathering. So one of the key kind of parts of the legislation is that the regulator's been very key to emphasize that a proportionate approach is needed when carrying out these assessments. It's not particularly explicit as to what proportionate means, but from kind of in terms of the work that we've been doing and the interpretations that we've made, effectively it's a primarily desktop and visual survey, at least initially. So it will be going through record drawings and doing site inspections to review the general form and layout of the building. Does it look sensible? Are the column grids kind of appropriate? Are the stability elements in the right place? Do the member sizes look about right? There'll be an element of site inspection to look for any kind of signs of distress or movement or anything that might prompt concern, particularly if there are elements that appear to be undersized and maybe we don't have calculations to kind of show that a transfer beam has been designed to work at a certain depth, and just a kind of an untrained eye who's looking at the drawing, beam looks smaller than it should be, or the transfer slab looks smaller than it should be, then you would go into a kind of more detailed review and assessment. The theory is that you're not necessarily looking for problems, you're just trying to kind of make sure that the building makes sense and is logical. And obviously the more information that's available, the easier it is to do that. And if there are gaps, you might need to fill them in due course. The assessment itself, the approach can vary depending on the nature of the building. So it could be based on past performance, particularly if they're quite old buildings that maybe predate sort of more modern design codes. They wouldn't necessarily lend themselves to a kind of more traditional calculation approach. So it might be a degree of looking at past performance in similar buildings and generally the condition of them. It could feasibly be based on calculations or kind of spot checks and review, scheme design guidance, etc. And also to some degree on investigations and further review. But I'll talk about all of that in subsequent slides. So starting from a kind of desk study basis, there's various sources of information that are kind of where you're going to get your information from. So the number one source is going to be the record information. And as per the previous session on the golden thread, hopefully the principal accountable person will have a full set of information that relates to both the original design of the building and then its ongoing use and operation. So that would hopefully include structural drawings, maybe reinforcement or fabrication drawings, depending on the materials that are used, drawings for other disciplines, such as architectural plans, building services plans with kind of services provision, particularly things like gas, and any services that may be run underneath the building. It might include specifications, testing data from construction, such as concrete cube strengths. Ideally, although we haven't had any of these really, calculations, or more likely you might find design philosophy statements where at least you have some clarity as to what the basis of the original design was. Things like ground investigation reports that might highlight any kind of particular concerns around aggressive ground or settlement, etc. And then fire strategy and compartmentation drawings, which will obviously be relevant from a structural fire resistance perspective. On top of that, there's a number of kind of broader documents that are very helpful in informing that risk assessment procedure. So there's various ICRIT documents, which I'll talk about some other examples, plus obviously the code that the forthcoming document that I've mentioned. Historic design codes are very helpful, particularly if you obviously know when the building was built, you can have a decent stab at what the overriding design requirements would have been at the time, and can therefore kind of review against that in terms of, say, element sizes or fire resistance of members. Scheme design documents are also very helpful in terms of looking at kind of initial sizing of elements to see if things look about the right size. Similarly, detailed design guidance can be useful in terms of informing what you're looking at. Manufacturer's literature, so things like load span tables for metal deck, for example, will help to give you a feel as to whether spans are appropriate as well. The Blue Book for steelwork is another example, and then the cross newsletters and reports are also helpful. Something that I think has been mentioned on these sessions before and is in the published more widely, the ICRIT have compiled a compendium of common types of higher risk buildings. So this document is available on the ICRIT website, and it gives some general steer on typical forms of building based on kind of age and visual condition, and helps to identify some of the kind of common issues that you might want to look for, as well as giving you a fighting chance of maybe understanding how certain buildings work, which, particularly if there's a shortage of record information, can be difficult when you allow for partitions and finishes and everything else that are going out of their way to hide the form of the structure. It's definitely a starting point. I don't think you could rely solely on the kind of steer from this document, but it might help to give you at least a starting point as to what you might need to look for. Other useful sources of information. So Technical Report 70 is very helpful, which kind of talks about the evolution of concrete design through the years, and again, can help then steer you to the appropriate design codes that would have been in place at the time of construction and inform your review. Other documents, so the recently issued guidance on transfer slabs, that includes sort of scheme design rules around kind of rules of thumb for how thick a transfer slab would need to be for different numbers of stories, which can be quite useful when you're doing your initial desktop study to see if the sizes seem about right. There's obviously guidance around finite element analysis, concrete and fire safety. So bits of that might be appropriate depending on the nature of your assessment and what you find. And if there are areas that are of a concern, it may prompt a more detailed review. I mentioned the cross newsletters. So these are effectively a prerequisite for anyone who's doing anything to do with the Building Safety Act, which is effectively all of us. So these obviously are very good at highlighting common issues and common concerns. Not everything will obviously be directly relevant to a structural risk assessment that you might be doing, but there's definitely things in here around balconies and transfer slabs and various common issues that are definitely well worth being aware of. And that's true of the safety alerts as well, which obviously highlight specific concerns. So definitely recommend that you're staying on top of these and signed up. Following the initial desktop review, it's then generally sensible to do a site inspection of the building before you actually get into any risk assessment. Obviously, you can learn a lot from a building from the drawings and from any kind of record information available, but until you've seen it in person, you don't have the full picture. Typically, at least initially, the site inspection will be non-intrusive, it will be visual, it will typically be limited to readily accessible areas. So you'll have common areas such as receptions, corridors, stairwells, plant rooms, car park areas, maybe retail properties if they're kind of used at ground level. In some cases, you'll have accessible rooftops. In many kind of apartment blocks, you'll also have podium areas with landscaping. You'll generally have access around the building perimeter, which will allow you to do things like look at balconies, for example, and get a feel for their form. Are there any obvious signs of corrosion, etc.? Typically, the residential units will obviously be off limits because they're occupied by people, and that tends to make up quite a large proportion of the building. So that is often a challenge. And even where you do have access to the building, often it's going to be hidden behind finishes. So it's a naturally kind of limited exercise, but you can glean quite a lot from a kind of thorough investigation of the areas that you can get to. The observations from this are then fed back into the risk assessment process. So you've got your desktop study and you've got your sort of site inspection and your observations, and the two of those together then go directly into the risk assessment process. It may be that you need to do further assessment as a result of that process and things that come out of it, but at least initially, generally a visual inspection is a kind of appropriate level of information to feed into the review. The challenge, obviously, is that even with all of that, you will often still find that you have missing information, and so there might be a need for further investigations to inform that. It's a statutory requirement to actually gather the information on the building and its structure, and as part of the risk assessment process, you do have to kind of effectively show your working and show what documents you've used to inform your review, and those documents then are generally included in the safety case report as an appendix so that the regulator has full visibility of what you've seen. What we have certainly found in the assessments that we've done is that generally you won't have all of the information, and there can be significant gaps, even for newer buildings where you might expect that kind of modern best practice would help to ensure that information is available. You might therefore kind of find the need to do further investigations. As a worst case, that might be on a larger scale opening up. So if you've got no record drawings of the building at all, and you can't even kind of definitively know what material it's made from or where the columns or the cores are, you might need to do some more deliberate opening up of partitions and things to try and get a feel for the frame of the building. Hopefully, more generally, it will be targeted investigation. So, for example, you might be doing cover meter surveys to try and review the cover to concrete elements from a fire or a durability perspective. You might want to do kind of local testing of intumescent paint to confirm its fire resistance, maybe sort of testing for the thickness of concrete slabs, for example, if that isn't really available from the information that you have. Any steps that you take to collect this information should be included in the report. It's all about effectively showing the process that you've gone through to the regulator. And it's important to remember the proportionality when you're thinking about further investigation. So, I mean, you could feasibly go in and start making holes in everything and confirm all of the reinforcement. But ultimately, if the building generally makes sense and the condition from what you've seen tends towards it being okay, that would effectively fall into kind of the non-proportionate approach. So it's kind of targeted areas. The challenge there, obviously, is that it becomes an exercise in engineering judgment as to how much investigation is necessary, how far can you extrapolate from a series of points, etc. So slightly different from what we might normally do in a design perspective. There's a lot more sort of thinking as an engineer as to what is an appropriate level of information for us to be able to make a statement, say the building is or isn't okay. If there is still missing information as well, then any risk associated with that should be recorded. So if you are sort of saying, we've done some investigation, we've reviewed a number of positions, generally these suggest that something is okay, you then can kind of make the point that we haven't tested every location, we are extrapolating from that data, but it's all about just being transparent about what has and hasn't been done. So that's the data gathering process. And once you've done all of that review, you have all that information that then feeds directly into the risk assessment procedure itself. As a general overview, the risk assessment is looking to identify structural and fire risks within the building that you're looking at, assessing the likelihood and the consequence of the risks as a result, and then identifying if steps need to be taken to mitigate those risks. So it's broadly the same as any other risk assessment that we might do. The BSA, it doesn't dictate a particular form of risk assessment, just that it's fit for purpose and that it matches the risk profile of the building. There are various ways that this can be done, and I'll come on to that. Typical outline processes as shown here from BSE and IEC. Broadly speaking, you're identifying hazards, you're doing an analysis as to the kind of risk associated with them and the consequences thereof, and evaluating them, and then working out whether you need to do anything with them. So it's a standard process, but it's kind of a new way of applying it to what maybe we're used to as engineers. There's specific guidance within HSE report RR1170, which gives some steer as to what the different sort of risk scenarios are for both structural issues and fire issues. From a kind of purely structural perspective, it's kind of fairly intuitive, but it's collapse of various levels. So you might have collapse of sort of local areas through to collapse of multiple floors, through to the whole building collapsing. There's specific concern around balconies or suspended walkways and making sure those are suitably addressed. Any attached or supported components, so that might be kind of large awnings or balustrades or handrails that provide a kind of key safety issue, both in terms of them falling and landing on people or residents being at risk from those sort of failing and people falling over the edge. There's specific concern around undermining or compromise of foundations and whether any works around the building might have an impact on its overall structural integrity. Aggressive conditions due to the ground or the environment or general kind of degradation processes that can impact the building. Specific incidents, so that could be things like gas explosion, it could be vehicle impact, potentially depending on the building, it could even be things like train impact or any other kind of local considerations that might come into effect. And then scenarios around how the building was built. So the most obvious one there is large panel systems. So the Brennan Point kind of scenarios where obviously you've got a particularly sort of dangerous failure mode, effectively, if things go wrong. But you might have sort of buildings that are built out of precast elements and making sure that they've all been sort of joined together in suitable ways. The document also identifies a number of fire risk scenarios. Generally speaking, these are kind of dealt with by the fire engineer as part of the fire risk assessment, or they certainly should be. But what you'll find is there is a degree of overlap between the two. So from a structural perspective, things like fire resistance will need to be thought about. and there might be elements of compartmentation that help to inform the structural resistance of the building, for example. So there typically will be a degree of conversation and interface between the structural engineer and the fire engineer. And it might be that there are scenarios where if there are question marks over the fire resistance of the building, say if concrete columns aren't in line with minimum element sizes for the design codes, that a degree of fire judgment and fire engineering may be required. So in terms of the hazard identification process, there's an example checklist in the ICRIT Guidance that's coming. This is a snippet from that, so it identifies some of the kind of common areas that you might want to think about. So the kind of the nature of the design, the nature of the building in terms of its kind of general form, whether there's anything particularly innovative or unusual around it, things like transfer slabs or cantilevers, that kind of thing. Thinking about different types of actions, the condition of the building, any observations, etc. So there's no kind of mandatory way to record this. The ICRIT guidance is there if you want to use that. Alternatively, as long as you're kind of going through a rigorous systematic procedure to identify any hazards, that's ultimately the key thing here. And again, it's important that you record your working as part of the risk assessment process so the BSR can see how you've gone about identifying those hazards. That then feeds into the actual hazard analysis itself. So as I mentioned, there's no specifically mandated approach to this within the Building Safety Act. What they do say is the hazard methodology is a straightforward approach that may be suitable, and then they go into some detail elaborating as to what that might look like. So although they're not saying use a hazard analysis, they do kind of steer you in that direction. But there are other approaches that could be used. Bow tie analysis is another way of doing it. Broadly speaking, as long as you're going through a process where you're reviewing the hazards and you're effectively saying, what if this occurs, what would the consequences be, and then assessing kind of process as to the consequence of those and how those could be mitigated, that's fundamentally what the approach is looking for. The key thing with whichever approach that you adopt is that there is sufficient independence as part of that review. So it's not a case that you've got a kind of group of people who know the building well and are kind of obviously generally unconsciously sort of going down a kind of blinkered approach where everything seems to be fine. You need to make sure that you have people with sufficient independence that they can ask questions and sort of think about things differently to make sure that you are identifying those issues. And that might be a kind of risk professional, depending on the nature of the building and the availability, but it could equally be a suitably competent engineer who's just there to kind of challenge and ask the right questions to help steer that process. That is then, however you kind of go about that process, captured as part of a hazard analysis. So you need to effectively set out what the hazards are, the thought process that's gone around the review of the risk and the consequences thereof, and then you ultimately would capture any mitigations that are needed. A few examples of kind of items that might be particularly relevant as far as the hazard review is concerned. So these are all things that we've found as part of the assessments that we've done so far. So I won't go through the full list, but the bigger ones tend to be things like transfer slabs or transfer beams and making sure that they're appropriately sized. And we've had some cases where they've been much smaller than the scheme design guidance might suggest they should be. Large panel systems is a particular challenge, and there's obviously been specific talks on that by the ICRIT, going through some of the particular complexities around those buildings, so that they're not a huge number of them in the grand scheme of things, but they do bring particular challenges. Other things, so concrete cover and element sizes, particularly from a fire resistance perspective, is a recurring theme. There's obviously minimum element guidance given in BS 8110, for example, and if the columns and the cover are compliant with that, then in theory that's nice and straightforward, but we're finding that's often not the case, and there's a reliance on compartment walls that are often not of the same rating as the structural resistance, and so there's still some kind of ongoing review as to what that means. Other things, so column discontinuity is a kind of common one where you might have columns moving on plan, you might have columns rotating on plan, or kind of walking as you go up the building, which would obviously be a kind of particular concern to make sure they've been designed properly. Global stability is another one, and making sure that you've got a kind of sensible proportion of both stability elements in the first place and that they're laid out in a kind of appropriate way to help to manage global torsion and global kind of cantilevering effects, for example. various things that might come out of the site inspections. You might have corrosion of steelwork or balconies or water ingress in basements, all of which need to be carefully thought about and managed. They might not be immediate safety concerns. So it might be that it's not something that's a kind of problematic risk at the moment, but if you don't do anything about it and you let it just continue for the next 5 or 10 years, it may become one. So it's about being proactive and managing risk. Another key one is around vehicular impacts. Often you do have car parks at the kind of base of large multi-story buildings. So it's making sure that suitable allowance and considerations are given to the potential for vehicle impact. It might be through sort of direct prevention by, say, columns being designed appropriately or having vehicle barriers. It may be more done in a general robustness and time perspective. However it's been thought about, it's just trying to make sure that it has been kind of suitably managed. One of the explicit requirements of Statutory Instrument 907 is that, as well as identifying those hazards and kind of reviewing them, you have to actually quantify them from a likelihood and consequence perspective, similar to most other risk assessments. The challenge here is there's not really any reliable statistics as of yet to help inform kind of likelihood of something occurring. Obviously, fortunately, there's a limited number of kind of big failures in buildings, certainly in the UK. So from a kind of general perspective, we know that there's not a kind of a number of these buildings failing, but whether a kind of local failure or a crack or serviceability issue generally wouldn't be reported. So there's definitely an element of engineering judgment to try and kind of assess what an appropriate likelihood would be. As a result, it tends to be more of a kind of qualitative process than a quantitative process. And it's really about trying to use your engineering expertise and your engineering judgment to decide whether a risk is unacceptable and needs to be kind of actively addressed in some way, whether it's generally acceptable and it's fine, or whether it falls into the kind of middle area where you maybe can't definitively say it's not a problem, but in the general balance of things, the risk is as low as reasonably practicable or a lot. And there's an example within the ICRIT Guidance around that kind of risk scoring. So you have, in this case, the green sort of zone at the bottom, where you've got generally tolerable items that are okay. The red area at the top right, where you've generally got a concern that needs to be addressed in one way or another. And then there's sort of band in the middle where all reasonable steps that can be taken have been taken. Generally, the item is deemed to be okay on balance. But this is the tricky bit as engineers, because we're dealing with uncertainty, and how we kind of manage and justify that is really the crux of this whole exercise. In terms of the actual kind of risk scoring, so the likelihood is the trickier bit. The consequences is obviously a little bit easier for us to think about. This is kind of consistent with what you would do on a consequence class 3 risk assessment, for example, where you can kind of have a reasonable stab at, if a column were to fail, what would the consequence be? Will it be localized to a certain area? Will it actually affect a large portion of the building? So this guidance is more or less verbatim with the consequence class 3 risk assessment guidance. So once you've been through that process, obviously the best case scenario is that you've managed to kind of satisfy yourselves that everything is tolerable or allowed and that there's no kind of further areas of concern. However, that's not always the case. So in the event of identifying any non-compliant assets, so generally that might be kind of elements within a building, or it could be the whole building itself, depending on how severe the item that you flagged are. There's then a whole sort of follow-up process of further investigation, further review. There's different ways of dealing with that. So it might be that it's a series of kind of more detailed analysis. So you might then go to finite element assessment or kind of more complicated calculation to either try and prove that something does actually work. If it's, say, a member that's smaller than you might expect it to be, it might be that it works perfectly fine if you do the kind of more detailed investigation. But again, it's this proportionate approach. So making sure that you don't go straight to building a finite element analysis model of the building on day one. It's more working through the process. And if you get to the point where you've got questions that you can only answer by doing a more detailed analysis, that's where it becomes proportionate. Alternatively, this is obviously all based around risk. So the other way of viewing it is, how can you control the hazard in a different way? So if the concern is that a particular column is sensitive to vehicle impact, rather than trying to kind of redesign and assess that column, you could potentially introduce some sort of vehicle barrier or other method of preventing that column from being subject to the vehicle impact in the first place. That's obviously part of a wider conversation with the principal accountable person, and you need to make sure that everything is joined up and that they're kind of on board with any proposals. But it's a bit different to obviously a new build design, where generally there's a way that you could kind of design something out. Here, the building already exists, so your hands are tied in a way that they aren't necessarily on a new build structure, and you need to think accordingly. Similarly, for fire resistance issues, I mean, this is obviously very much been in the press around cladding issues and everything else. As I mentioned, if there are fire resistance issues in relation to the actual structure itself, that can be trickier, and there's definitely a need to interface with the fire engineer to work out how best to address those. And it could be as far as actually doing full-blown fire engineering assessment and modelling. It's again just a case of making sure that approach is proportionate at all times. And considering that proportionate, so this is the kind of the key bit of the Act, and it defines this term, all reasonable steps, albeit it doesn't really define it, it just flags its existence. So what this is getting at is just making sure, one, that you've kind of gone through the process and you've taken the reasonable steps to both identify the hazard, quantify it, to assess its impact and likelihood of it occurring, and as far as it's kind of reasonable, managed it. So taking that example of the car park column, for example, you could feasibly, if you had question marks over the size of a column, you could do full-blown analysis, you could do strengthening, you could do all sorts of things to try and address the column itself. But that potentially is a kind of overkill way of doing things. And actually, is it easier to work with the principal accountable person to ensure there are speed limits in place, that there are limits on the sizes of vehicles that can kind of enter the car park? Could you introduce some sort of protection to the columns, be it bumper rails or external barriers, etc., and manage that risk in a different way that's less impactful, ultimately less expensive and less disturbing to residents? The key thing is that you can kind of show that process that's been gone through, and you've taken those reasonable steps, and you've made an active assessment of the risk, and you've made an active choice to address it in a certain way. And that's really what the regulator's looking for. If you've maybe identified a risk and just kind of dismissed it without kind of any real kind of explanation as to why you've done so, or you've just kind of overlooked it completely, that's where the regulator will start to raise challenges and to push these things back. And then if you've been through that process and identified something that is unacceptable, that then triggers its own process. So as an example, if you've done a review and you find a transfer slab that just does not seem to be appropriate, it's too thin and you can't kind of readily find a way to justify it, that then triggers the kind of mandatory reporting process. The actual BSA itself doesn't set a benchmark for what it deems to be an unacceptable risk because it's a principles-based legislation. However, SI 907 does give some indication. So it has these two terms, which defines a safety occurrence. So that's effectively an issue that could lead to a risk condition being met, which typically might involve kind of collapse of some or part of the building. And then the risk condition itself is effectively if that risk is of sufficient magnitude that you fear it could kind of manifest itself and lead to the significant injury of a number of people. If you kind of hit those two criteria, then that is a mandatory reporting exercise. So that would then be reported to the building safety regulator, and you would need to work with the principal accountable person to take appropriate steps to mitigate that risk. So if, for example, it was a transfer slab, it might be as an interim stage that you would need to do some temporary propping to address the concern ahead of a kind of wider series of remedial measures being developed and put into place. That's obviously the worst case scenario, but it is worth remembering that just because a building has been standing up for the last 10 years doesn't in and of itself guarantee that it's okay. We've had cases where we've had buildings like that sort of no obvious signs of any distress or disrepair. But when you actually kind of look at them on paper and you kind of run some high level numbers, you've got utilizations well in excess of 100%. And it's just through kind of sheer luck to some degree that they haven't actually manifested themselves in a failure. So definitely don't kind of just take the fact that a building is there as proof that it's okay. In terms of that guidance, so keeping up to date, there's obviously an ongoing update of the resources on the ICRIT website at the link above. The actual guidance document itself, as I mentioned, is going through the final check and review process, and that's anticipated for publishing in August. It's available for pre-order at the moment. There will be a webinar that goes out alongside this issue, which will go into a bit more detail about the actual nuances of the document itself. I've obviously been talking at a slightly broader level as part of this presentation. There's also all sorts of other information on the iCRIT website, as well as the other recordings of these sessions too. So it's very much a kind of an evolving understanding, both for the iCRIT and for the regulator itself. So do keep checking back and kind of try and stay on top of these things, because the guidance and the best practices is evolving as we go. And just as a kind of final point, so as Dame Judith noted, so true and lasting change will require a universal shift in culture. This is quite a different way of us having to work as engineers. The actual risk assessment process itself obviously isn't new, but often we're doing it in the context of things that haven't been built yet, or things that we are designing, and we're in a position where we can control and manage those risks through our design. Here, the buildings already exist, so you're dealing with a completely different risk profile and a different challenge. There is a degree of overlap with what we do for refurbishment, for example, but obviously here it's trickier because we generally don't have the same level of information and we're reporting in a different way. So it's definitely an adjustment. Hopefully the guidance and this talk will give you a bit more of a feel as to what that process needs to look like. And yeah, good luck on any future assessments.